True positive, false negative, true negative. So, what do these mean, and how do you measure the success of a machine learning model? Well, the most popular way to measure it is through these kind of true positive and true negative ratios, and there's different ways you can kind of combine them to kind of measure the accuracy. And I'm going to go over some of the more popular ones. But I wanted to go through kind of conceptually what is something called a confusion matrix, and I encourage you to Google this. If you go to images.google.com, you Google this, you will find lots of different diagrams. Be careful because some of them put the prediction on the top side, some of them put prediction on the left side, and then the actual on the other side. So uh, I don't encourage you to memorize these charts, but more importantly, how do you kind of conceptually think about them, and how do you calculate them? The exact formula, you can always Google that, but the kind of conceptual kind of understanding of that's something that we'll walk through. This is kind of what you'll find when you type in confusion matrix to images.google, and if you type it into the web search, you'll find some articles, and this one I think is a pretty good one. One of the first top results is from this site called Data School, and even though it's dated from 2014, they have kind of like a general chart and how each of these kind of can make sense of. So on the top side you have uh, predictions, and on the left side you have actual. And when you measure the success of machine learning model, generally you want your predictions to be pretty close to the actuals, right? So that's generally like true positives. The way you read it, TP, you read it from left to right, but I found that from a conceptual perspective, if you read it from the right to the left, it's actually easier. So if you think of you know this one says these are cases in which we predicted yes, like they have a disease, and they actually do have a disease. So P on the right side is what you're saying. You're predicting that they're positive for a certain disease, and the actuality one is the one on the left, T. So that's true. So if you predicted they have a disease, do they actually have a disease? Yes, they do have a disease. So in that case, that's a true positive. So on the other hand, if you predict that they don't have the disease, this is a negative. They don't have the disease, and you're correct. True, that's correct. Then that's true negative. So you correctly said that they do not have a disease. So you predicted no disease, and true, that's correct. They don't have the disease. Now, a false positive is if you predict a positive, meaning you predict they have the disease, but they actually don't have the disease. That's false, right? So we predicted yes, but they don't actually have the disease. That's in statistics. If you've taken a course on statistics, that's known as a type 1 error. And notice that the type 1s and the type 2s are basically when you have false things, right? First one is a false positive, and the second one is a false negative. So the two falses are your traditional statistics type 1 and type 2 errors. So again, you go from the right to the left. You predict that they don't have the disease, right? We predicted no, but that's incorrect. They actually do have the disease. So that's a false negative, right? So that's what you're known as a type 2 error. All right. So once you kind of make sense of these guys, and you put them into a 2x2 matrix, if you have your predictions here on the top and you have your actuals on the left, then if you predict yes and it's actually yes, that's a true positive, right? So that matches up with this, right? Yes prediction on the right side, remember, and then yes confirming that whatever you did over there was accurate. That's a true. So that's where that true positive comes in, right? So what about over here? You're predicting a yes, which is that right hand side P, but that's actually incorrect. That's a false positive. So actually it's the opposite of what you have here, right? So that's a false positive. And over here you're predicting no, they don't have the disease, and that's true. You don't have the disease. All right, so that's a true negative. And then over here you're predicting they don't have the disease, but that's false. They do have the disease. That's a yes. All right, so that's how you make sense of it. And you can kind of do different ratios. So some of the most popular ratios are listed here. We talked about true positive, false positive, true negative, and false negative, which is somehow not listed here. But they have other ratios here, such as precision, which are popular. There's accuracy is the one that's kind of like the most well known, where it's like all your trues divided by your totals. But there's also something called recall, and here we're saying that recall is the same as the true positive rate, which is really the true positive divided by all your positives. So in this case, you have right. So in this case, your true positive is in this box. That's 100, and you want to divide it by all the positives. If all the people who actually have the disease, right, actually have the disease, that's a yes, actual yes. And so the total for this would be 105. So your true positive is 100, and you divide it by 105, and that's your ratio. So it's whatever this 100 divided by 105, that's your percentage for recall, right? So another one a lot of people talk about is precision, and so that's true positive divided by the predicted yes. So, like conceptually, it's when you predict that somebody has disease, how often is it that they actually that's correct, that they actually do have the disease, and in this case, it's this true positive 100 divided by the total out of the predictions that somebody had disease. That's 110. So in one case, you're dividing 100 by 105 for recall, and for precision, you're dividing that 100 by 110 for precision. And there's a lot of people talk about this kind of balance or trade-off between precision and recall. The way I tend to remember which one is which is recall is the one where I use the analogy with catching a terrorist at an airport. So if you think conceptually, like here's an image from TSA going through security at an airport. In this situation, it's really bad if a terrorist gets through, right? So you really want to make sure that you capture every single positive. If someone is positively a terrorist, you want to make sure absolutely that you are able to spot them, that the machine learning model is able to catch this one, because the consequence of missing it is really, really bad. So what does that mean in terms of this chart, right? So if they're actually a terrorist, you want to make sure that you absolutely catch them with your true positives, and that your false negatives is minimal, right? You really don't want to predict that they're not a terrorist and then you're wrong, right? So when it comes to terrorists, you want to prioritize recall over something like precision, right? So you want to prioritize having the ratio of 100 over this 105 number to be as high as possible, because you want this false negative to be as low as possible. And that's recall, right? Again, recall is this row here, whereas precision was the true positive divided by the 110, right? So that's a different kind of metric. Precision is when you predict someone's a terrorist, that they indeed are a terrorist, right? So that's when you predict that they're a terrorist, how often are you correct? That's precision, right? So when it comes to something where it's really, really bad to miss, you want to prioritize, generally speaking, recall over precision. And again, that's the calculation of true positive. You want to minimize your false negatives. So going back to this, some of these charts, thought this one was interesting, so just kind of bringing that one up. Um, Recall again is when you want to reduce your false negatives, because it's really really bad if you predict someone's not a terrorist and that's false and they actually are a terrorist, because then you let them through the gates and they get into the plane and they blow things up. All right, so that's when it's really really bad, and so you should prioritize recall in this situation. Whereas precision, you're more concerned about reducing your false positives. All right, so that's precision and recall, and so you can kind of think of, and again this chart is again what I cautioned you earlier about predictions on the left and actuals on the top. Whereas in previous examples, this one, for example, predicted when prediction was on the top, actual was on the left. So don't try to memorize the chart. If you do, be aware that these possibilities exist, but rather try to understand the concepts. And so in this chart, if you have predictions on the left and actuals on the top, you have positive and positive, negative and negative. Then your true positive would be on the top left, and true negative would be on the bottom right. And so here they wrote out the kind of formula for recall. They wrote out the formula for precision. For precision, that's basically true positive divided by the top row, right? Whereas recall is true positive divided by the vertical column. So one is the row, the other one's the column. And here they're defining accuracy as the diagonals, true positive plus true negative divided by the sum total. Right? So these are kind of three popular measures, of course, mentioned in that blog. There's some others, other ones like specificity, which is like 1 minus false positive rate, and prevalence, and different kinds of things. And there's just things called F scores, and those are all different ways to measure it. And depending on your project, you may want to prioritize one over the other. But these are just kind of general kind of ways of evaluating a machine learning model. And when it comes to picking which metric, the airport analogy that I alluded to earlier is a good one to think about which metric matters more and which one you want to prioritize more based on the context of what you're dealing with. So again, in this particular context, with terrorists getting through, you really don't want that to happen. You don't want that false negative, and therefore you want to prioritize having a high recall, a low false negative rate. So in summary, I encourage you to Google the word confusion matrix. You will come up with lots of different diagrams. Be aware that many of them are kind of drawn out one way, and another one could be drawn out another way. Just be aware that that exists. In general, with recall, you want to minimize your false negatives. You want to minimize the chance that you let someone through the airport and make that really heinous bad mistake. Whereas precision, you're focusing on a different metric, and there's multiple ways of measuring the success of a machine learning model, and ultimately choosing which one depends on the context of which problem you're dealing with. So there you have it, confusion matrix. This is Alan for Udacity.